Today we're going to go over some similarity here, and we'll talk about it, and then there will be 2 assignments on it for this week. Similarity is actually fairly easy. Key 2 things you want to remember about similarity, I'm going to write these right here at the top, is that 1, the angles of the figures must be congruent. That is, the corresponding angles of the figures must be congruent. So I'm going to write that down. Corresponding angles, all corresponding angles, have to be congruent. In order for figures to be similar, all corresponding angles must be congruent. And then the side lengths must be proportional. Now, proportional means 2 fractions that are equivalent. 2 fractions that are equivalent. So a lot of those equations we were doing last week with the proportions, where you had like x over 3 equals 2 over 7, and then you had to cross multiply and divide to solve. Those are the type of things that we're going to see as we do these similarity statements. So first of all, let's just talk about it. So let's say we had these 2 figures right here. Let's assume that all the corresponding angles are congruent. How would I write a similarity statement? Okay, now look at those 2 figures. Which angles are corresponding that are the same measure? Which angles would be corresponding because they would have the same measure? The easiest one to look at as you look at these is the x and the c. Notice the x and the c are kind of sharper angles. So those 2 must be our similar corresponding angles. So I start there. Now notice the shorter side extending from C goes to D, not to B. Can you see that? The shorter side going from C goes to D. So on the other figure, X goes to what as the shorter side? So again, on the figure on the left, C goes to D as the shortest side from C. On the figure on the right, knowing that C and X are corresponding angles, X will go to what as the shortest side? X to Y, right? So Y has to correspond to D, because those made our shortest sides. Then I just go kind of around in a circle, if you will. I'm going to go to Z. What corresponds to Z? Obviously A. And you'll notice that I'm putting 3 marks on Z and A, 2 marks on P and Y, 1 mark on X and C. That just is to show that they're corresponding. My last one is going to be the corresponding angle W. I'm going to put 4 marks there. Which one does it correspond to? Obviously B. Now, what we have here are 2 similar figures, but they want me to make a similarity statement. So knowing that these angles are congruent, I'm going to make a similarity statement. So my statement is going to be, I can just write it any order I want. I'm just going to go A, B, C, D, right? And that is a quadrilateral. So that's how you draw quadrilateral A, B, C, D. And then I write this symbol right there. It looks like an ñ if you're doing Spanish over the N, but it's that means similar. So just like we have equal or congruent, it's the little symbol above congruent also is this little squiggly, and that means similar. So just think of a S laid down on its side, and that means similar. So if I say ABC is similar to, I have to write the corresponding angles. So I'm going to say it's similar to the quadrilateral, and then what am I going to say it's similar to? Well, if I start with A on the left, I've got to start with what on the right? A has 3 marks. Over here on the right, Z has 3 marks. So I'm going to say, okay, this corresponds to Z. Now what corresponds to B? Notice B is the second in line. So what corresponds to B? So B has 4 marks. W has 4 marks. So I'm going to say Z, W. Then it says C. C has 1 mark. X has a mark. And lastly, D has 2 marks. Y has 2 marks. do not just assume that these are going to be alphabetical. So notice the figure on the left, I just said A, B, C, D. Don't think the other one's going to be W, X, Y, Z. It doesn't follow that way. It's whatever angle is corresponding. So notice A corresponds to Z, B corresponds to W. They are the same measure. That's how we could say they're corresponding. And C corresponds to X, and D corresponds to Y. So that's how we make what we call a similarity statement. You can do that with any triangle or quadrilateral or even a pentagon or whatever. Any enclosed figure where all angles are congruent makes them similar, and you can do a similarity statement. Okay, moving on. The next type of question is going to deal with proportionality of sides. So this one's going to say, all right, are these figures similar? And you can say, oh yes, they are similar. You can see that the angle on the left is similar to the angle on the left of the figure on the right. So there's two figures, the one on the left, the one on the right. The angle on the bottom left is similar on both figures. Top of both figures, the angles are congruent. Bottom right of both figures, the angles are congruent. So therefore I know those two figures are similar. Now I have to set up the proportionality to solve for X and Y. So I'm going to set up some proportionality over here to the side. So I'm going to write, so notice that the similar sides then are 2 to 4. This 2 to this 4. So I'm going to write 2 over 4 equals. Now, the key is to make sure that you set up your proportionality with the correct ideas. So what I'm saying there is, notice 2 comes out of the figure on the left. So I'm going to write a little L out to the side. That signifies that this is the figure on the left. I'm going to put a little R down here telling me that this is the figure on the right. This way I don't get confused and I don't put them in the wrong places. So the lefts will always go on top, the rights will always go on bottom. Okay, so now we just have to put corresponding sides over each other. So here I put 2 over 4. If I'm solving for X, what am I going to write? Well, the figure on the left that corresponds with X is this 4. So 4 corresponds to X. So I need to start with the figure on the left. That's what's going on top. That's where the 4 goes. X goes on bottom. Now I just cross multiply to solve. Now before you cross multiply, reduce if possible. It makes your life easier. It just makes everything smaller. So I'm going to reduce that 2/4 to 1/2, then cross multiply. 1 times X, see how easy that is X. 2 times 4 is 8. So X is 8. Now let's set up an equation to solve for Y. So here's the Y. It's this long side. And here's the 6. So I'm going to say, all right, can I use the same 2 over 4? Absolutely. So whatever they give you where you have two similar sides, two corresponding sides allow you to set up a similarity proportion. So I'm going to set up that 2 over 4 again. That way I'm using the same type of thing. And I'm going to use that to solve for Y this time though. So what side corresponds to Y over here in this figure? Obviously it's the 6, right? So I want to write the 6 on top though, because the 2 came out of the one on the left. Therefore the 6 comes out of the figure on the left. Notice both those come out of the left. On the right, the 4 came out of the one on the right. Therefore the Y has to come out of the one on the right. I could cross multiply right now. I don't have to reduce, but like I said, reducing makes your life easier. So I'm going to make it reduced. 2 over 1, cross multiply. Y equals 12. And there's my values. So you'll have some problems like that. Next one right here. This one's going to ask you, all right, tell me if these figures are similar. And if so, how do you know? I'm going to show you an interesting little thing that happens here. Now, obviously, we're going to compare what we call scale factors. So the figure on the top is to scale with the figure on the bottom. What that means is that their side lengths are proportional. We're just going to show that. So again, I'm going to write 5, which is the figure on the top, so I can put that out here to the side, over its corresponding side on the bottom. So bottom, what's the corresponding side to 5? Well, obviously it's 10. Equals what? Well, we're going to go top to bottom. So the right side of the top is 2, and the right side of the bottom is 4. Now, are those equal or not? Well, there's a couple ways to do it. One simple way is to simply cross multiply. Don't reduce or anything, just cross multiply. What would I get? 20, 2 times 10 is 20, and 5 times 4 is what? 20. If those equal each other, you know that these are similar. Another way to do that is to reduce. So I could reduce 5/10. 5 goes into 10, 1/2, and see if it equals the other side reduced, 1/2. If that's true, they are similar. So you either reduce or cross multiply. Either way, that proves those two figures are similar. So you should have something out to the side. When I ask you to show your work, you should have this ratio set up out to the side, and then I either want to see it reduced so that they are the same, or I want to see cross multiplication showing that when you cross multiply, they're the same. This is what I'm talking about when I'm saying show your work. Don't just put yes, they're similar, or don't just put no, they're not similar. Show your work. Show that you set up a proportion, top to bottom, corresponding side to corresponding side. Then show that you reduce them or show that you cross multiply them. Okay? Either one of those is acceptable. Okay, next one. You're going to have two figures like this. You're going to have LNM and you're going to have ACB. LNM, all the sides are going to be filled in, and then ACB, none of the sides are going to be filled in. And you're going to be like, what? Well, it's then going to say, okay, ABC is not to scale. What is BC and AC if the figures are similar, is what it's going to say. Well, now it's going to tell me AB is 1. So I want to think about this. If I put in a 1 there, what sides are, it says ABC is similar to LMN. So ABC is similar to LMN. All right, so if the A is 1, what ratio would I set up to solve for BC and AC here? So I would say, again, just looking at this, I can start either left to right or right to left. I'm going to start with a smaller one on top. So I'm going to say the one on the right is 1 over the one on the left is 6. That equals, now I'm going to put, okay, 1 over 6 equals. So I'm going to let BC be my x value, and I'm going to put its corresponding side on the bottom with the figure on the left. So BC corresponds to 4. So I'm going to put that over 4. Cross multiply and solve. So this is going to give you 6x multiplying across there equals 4. Then I'm going to divide by 6 and reduce. X equals, or this is actually BC equals, and then 4/6 reduces to 2/3. Okay, so that's how that's done. Now I'm going to do the same thing. I'm going to do this one out to the right here. Using the same thing, I just want to find this time AC. AC. Okay, so looking at this figure, using 1 still, I want to try and use this AC. So my ratio is still going to be, okay, right and left. I'm going to say, I'm going to let this be, okay, X, or Y. I'll let it be Y this time. So I'm going to let that be Y. I'm always going to let this one be X, and I'm going to let this side AC be Y. So, all right, I want to go again. Either right to left, which is because I did it last time, I'm going to do it the same way this time. Or I can go left to right. It just doesn't matter. Just make sure that their corresponding sides are on top or bottom. So I'm going to go right to left, and I'm going to set up my equation, the one on the right, 1 over 6, those are the corresponding sides, right to left, equals, and then this time I'm solving for y, so I want to write the one on the right is y over 8. Cross multiply again. That's going to give me 6y equals 8. Divide by 6. Reduce, y is, now this one 2 goes into both, 4/3. So that is AC. Okay. Same thing for this 3. Okay. So using the 3, and I want to solve the same way. So now I just do the same thing that I was doing here, only instead of 1, what am I going to put on this top one? I'm going to put 3. So it's 3 over 6 equals, and then I'm going to put x over 4. Those won't change, that x over 4, because notice this is x, this is 4. Those are the corresponding sides in the two triangles. So, but the 3 over 6 changed because now AB is 3. Now this length is 3. That's why it said not to scale. So now we're saying that's going to be 3. Well, 3/6 reduces to 1/2. That makes my life easier. Like I said, I'm going to cross multiply 2x equals 4. X equals, dividing both sides by 2, x equals 2. Okay? Same thing over on this side. Again, we're going to say, all right, we still have, instead of 1 though, this is now changed to 3. So this is not 1 anymore. It's now 3. So we're going to say, all right, 3/6 equals, now we're going to do y over 8. Again, I can reduce that to 1/2. Cross multiply 2y equals 8. Y equals 4, dividing both sides by 2. Okay, so this y equals 4 is actually going to be, for this one, it's going to be your AC value. Okay, and that's how you do each one. Well, it gets a little more complicated when you're using the 7, a little bit, just because it's going to end up being a fraction. So now I'm saying, okay, this is no longer 3, it's a 7. Okay, so now I'm going to say, all right, AB is 7. So therefore I have 1 on the left, or 1 on the right, sorry, is 7 over 6 equals, and then I do the same thing here, x over 4. Cross multiplying, 6x equals 4 times 7 is 28. Divide by 6, divide by 6, just reduce that. X is, it's okay to get a fraction, and you're going to end up with 2 goes into both. That's going to be 14 thirds. Okay, same thing, 7 over 6 equals, so this is now 7, this is now 6, equals, now I'm doing the y over 8. Notice this y over 8 hasn't changed on any of these problems. Cross multiply and solve. 7 times 8 is 56, equals 6 times y. Divide by 6. X equals, again, 2 goes into both. Half of 56 is, half of 50 is 25. Half of 6 is 3, so it's 28. Over, and then half of 6 is 3. Okay? Now, the last one is kind of tricky because it says, what if we just used x? Well, okay, well, I was using x here, so I don't want to use x here anymore. I'm going to call that z now because they all of a sudden got this x in here for me. So I'm going to say, okay, let's figure this out then. So now I would have, all right, I'm going to have x over 6. So remember, this is not 7 anymore. This is x. So it's x over 6 equals, now we have this side z, which is what I want to get by itself eventually, over, and then we want to put that over 4. Cross multiply, and I end up with x, 4x equals 6z. I want to get the z part by itself, so I'm dividing by 6. Now this actually kind of represents a scale factor when you reduce it. It's 2/3 of any value of x. So no matter what I put in here, this was 2/3 of the value. You'll notice that as we go back. So when I put in a 1, notice 2/3 of 1, or 2/3 times 1 would be 2/3. 2/3 times 3, think about that, times that by 2/3, that would be 2. The 3's would divide out. 2/3 of 7, 2 times 7 is 14 thirds. So this 2/3 is kind of like a scale factor. That's the scale we're using to solve those, okay? Sorry, I might have did that again. So let me go over that again. Sorry, my camera was off. So again, if I have 1 times this scale factor of 2/3, 1 times 2/3 would be 2/3. 3 times 2/3, 3's would divide out, that would be 2. And then if I use this one with 7, 7 times 2/3, 7 times 2 is 14 thirds. So So notice this 2/3 really represents the scale factor. That's why they're having us do that. That equals z, or as you would say, it would equal bc. Same thing over here on this side. So again, now we're going to let this be x, and we're going to solve for this y. So I'm going to say, all right, I have x over 6 equals y over 8. Cross multiply and solve for, I'm still solving for that y value. So I have 8x equals 6y divided by 6. 8 6 reduced is 4/3 of x equals y. So on every one of these problems, this 4/3 of x will equal y. So whatever the x value was, it doesn't matter. If I times it by 4/3, I'm going to get the y value. So if I look back over here, and I say, all right, if it's 1 times 4/3 obviously was 4/3. That's the first one. If I use 3 times 4/3, that one was 4. Sorry, I should have circled this one. That one was 4. All right. And then lastly, if it's 7 times 4/3, 7 times 4 is 28/3. So you'll notice that this represents what we call the scale factor. Every time you would times it by 4/3. Okay? All right. Then you're just going to have a similarity statement. So this is the similarity statement. And then you're just going to match up the corresponding angles and sides. This is pretty easy, actually. So what corresponds to A in the statement? Well, L. Okay, so this is angle L. Very simple. Okay. B, C, A. So it's got to follow in that order. B, C, A. So what order do we need to have over here? If it's LPN, well, I started with B, so I got to start with P. I then have C second, so I got to have N second. And then I have A last, I got to have L last. So that's how you'd say angle PNL corresponds to BCA. Now I have B to C, so it has to be what? P to N. Very simple. C to A, N to L. Very simple. So those are pretty easy. Okay. Then you're going to have a question like this. It's going to give you some lengths, and it's going to say, hey, are these similar or not? How do you know? This one's a little bit tough. You have to think about it. You have a triangle ACD, so that's that triangle right there, and you're going to see if it's congruent to the other triangle. What other triangle is there? There's only one other triangle, ABE. So the big question is this whole length divided by this whole length the same as this partial length divided by that partial length? If it is, they're similar. If it's not, they're not. So I'm going to do the whole length and then the versus the partial length. So let's do whole length to set up our ratio. So the whole length, 90, and the whole length of AD is 133. So we set up that ratio. Remember up here, they both equal to half. These should equal the same thing. Now I'm going to use a decimal, but it's the same thing. I could have used, up here I could have used 0.5 and 0.5. Here I'm going to say, all right, what is that? Well, that's, that 90 divided by 133 is 0.667. So if that's the case, if 90, the top, divided by the whole bottom is 0.667, then this 21 divided by 25 better be 0.667. Is it? Well, I don't know. I'm going to punch that into my calculator. 21 divided by 25 is 0.84. Are those the same? If the answer is no, then those are not similar. Okay, no, not similar. Okay, the last type is right here. Are these similar? Now this is back to the angles. Notice no side lengths are given. You're just looking at the angles. How many angles have to be similar in a triangle for the triangles to be similar? The answer here is if you have two congruent angles, the triangles are similar. We call this angle-angle similarity. Okay? So I'm looking for two angles that are congruent. Well, obviously E and D are congruent because they're both marked as right angles. Is there any other angle you know any information about? Well, nothing else is marked, so you might say, well, sorry, I only have one angle, so therefore I don't know they're similar. But you'd be wrong. The reason is that ABE, and CBD are a special type of angle. What type of angles are those? ABE and CBD. What do you think? What type of angles are ABE and CBD? These two angles right there and right there. If you'll remember, those are called vertical angles. And those vertical angles are congruent. Now I have two angles in the triangle on the left and two angles on the triangle on the right. Therefore, they must be similar. Now remember, similar doesn't mean congruent. It just means that the side lengths will be proportional and the angles will be congruent. Notice, by the way, that A and C, even though they're not marked, have to be congruent, because if these two are congruent and these two are both right angles, all the angles of a triangle have to equal 180, so the C and the A also must be congruent to each other. But how would I show that? I would say by vertical angles, so this is again showing your work, by vertical angles, angle ABE is congruent to, now notice if I say ABE, I've got to use my corresponding parts and say angle C corresponds to A, B corresponds to itself, B, and then D. D corresponds to E. You'll notice that in the figure. Okay, so that's how I show my work. By vertical angles, I know I have angle-angle similarity. Therefore, this triangle ABE is similar to the triangle. And again, the order is super important. If I start with A, I got to start with C. If I have B in the middle, I got to have B in the middle here because B corresponds to itself. And then I got to go to D. And that's my answer. Triangle ABE is similar to triangle CBD. Okay, I'm going to send you 2 assignments. You need to complete those and have those in by the end of the week. Thank you.